Thank you for joining us today, morning, afternoon, depending on your time zone. I'm going to go through a brief agenda and then we'll introduce the facilitators that we have with us today, including myself. And again, for those who are just joining us, I'll keep posting this intro survey here. So this webinar workshop is all about mentoring undergraduate researchers, brought to you by CUR and also by CalBridge, a scholarship mentorship program run out in the state of California, partnership between the UC and CSU systems. So as I said, we'll do introductions of our facilitators here in a moment, so you know who's talking and where their background and experiences is coming from for each of these lovely people. Then we'll go through a brief things to know about undergraduate research from various people's experiences, and then get into some actual best practices. So there's a couple of resources. The EP3 guide, if you're not familiar, will highlight some specific things from that, as well as some specific tools that you can use when mentoring undergraduate researchers. Then after that, we'll go through and look at some case studies. We've got 2 case studies for you today, utilizing those tools so you can sort of see how they might work and how you might utilize them in your own research group. And then lastly, we'll finish up with some resources that might be useful for you or others as well, and then final feedback. So that's our plan for our time today. And again, I'll be dropping random things into the chat as we go along. So I'll start with introductions, and I'll start with myself, and I'll actually stop sharing for a moment so you can see our faces a little bit better. So I'm Carol Hood. I'm an Associate Dean in the College of Natural Sciences at California State University, San Bernardino. So that's a regional comprehensive institution, although I've also taught at a small liberal arts public institution in Georgia. And then my education was all at R1 institutions. I'm the chair of the Physics and Astronomy Division for CUR right now, although we are actively looking for new folks to come in. So let me know if that sounds interesting to anyone. And then I also am the director for the undergraduate program for CalBridge, which is where I've brought in some other folks, sort of merging these two organizations together for this webinar today. So I'll go through and call out some of our different facilitators and folks that we'll have working with us today so they can go through and introduce themselves and briefly talk about where they are in their careers and where they've been before. Oh, and I'm an astronomer by training, in case anyone's curious. Ted, why don't you start us off?
Hi, welcome everyone. I'm Ted Dezen. I'm a professor in the Department of Physics and Biophysics at University of San Diego, which is a private, primarily undergraduate institution. I am a theoretical and computational astrophysicist by training, and my education was all at R1s as well at UCLA and UC Santa Barbara. And I'm currently a CUR Physics Astronomy Division representative. And again, welcome to all of you.
Hasitha, do you want to go next?
Yes, hello, I'm Hasitha Mahabaduge, Associate Professor of Physics at Georgia College and State University. It's about 1.5 hours south of Atlanta, the designated public liberal arts university in the state of Georgia. We are part of the university system of Georgia. And my background is in condensed matter physics, more specifically in solar cells. Physically, right now, I'm at UNC Charlotte, attending a southeastern section of APS with 5 of my undergraduate students.
Great. Justin, why don't you go next?
Justin Brax. I'm a 6th-year graduate student at UPenn and a visiting student at Caltech. I'm an instrumentalist and astrophysicist. I'm also the co-chair of CalBridge's Alumni Council. And so my duties there include designing and facilitating various programming for CalBridge's doctoral program, which is a professional development and pedagogy training program that doctoral scholars undergo for 4 years throughout their PhD progress. Before I entered grad school, throughout undergrad and for undergrad, my job was teaching ballroom dance teachers how to teach. And then I moved into teaching ballroom dance instructors how to teach their new instructors how to teach. So the meta levels go very deep, and that's translated really well into my own teaching in grad school, but also in just thinking about the actual underlying methods of teaching and mentorship. And so that's why Carol has me here.
Right, Becky.
Hi everyone, my name's Becky, and I am also a sixth-year grad student at Georgia State University in Atlanta. I'm a stellar astronomer. I'm also located in California, working at the Center for High Angular Resolution Array, Astronomy Array, as a telescope operator part-time. And I'm part of CalBridge's doctoral scholar program, so I'm here to help out.
Thanks. And then Mike was our last planner if he wants to introduce himself.
Hello, everyone. I'm Mike Jackson. I'm Vice President for Academic Affairs at New Mexico Institute of Mining and Technology. I'm a physicist by training. And I'm also a divisional representative for the Council on Undergraduate Physics in the Physics and Astronomy Division. Carol, I'll turn it back to you.
Great. I'm actually going to turn it over. I'll start the screen share again to get us started on our introduction to Hasita.
Thank you, Carol. So, as you just heard, we are from different disciplines, different experiences. So, what we need to first throw out here is the disclaimer that ideas and comments that you see here are based on personal experiences, and this is not an exhaustive discussion of the important issues. And most importantly, all the problems, issues, and challenges that you might face are local. So next slide, please. Before we start, I can start with a quick operational definition for undergraduate research. When we talk about undergraduate research, this is what we have in mind. And this is based on CUR's adaptation for undergraduate research. The central premise of undergraduate research is the formation of a collaborative enterprise between student and mentor, and trying to address these four C's, what we call the creativity, critical thinking, collaboration, and communication. As I said earlier, today I came with 5 of my students just to address the last part of communication, so then they know how to present themselves. And to get to that point, then they have to come up with either their research project, or I guided them with some of the research projects. And then, so this is what the undergraduate research operational definition that we are using for this webinar. Next slide, please. And so, if I start from going all the way back to my kind of own experience, now, as I said, I'm at Georgia College and State University, which is a PUI. And when you come to a PUI as a physicist or astronomer, you might be the only person in that particular field. So the rest of the people who might still have physics or astronomy PhDs might not speak the same language. Therefore, sometimes it's not sometimes, always find a mentor. It could be one of your senior faculty members. If you are if you are the only person in that particular area or discipline, maybe go outside your department or even institution to find a mentor, because it would be helpful to have that background and a safe net to kind of fall down if there are any questions that you may need to answer. So, and develop a research plan and discuss it with the trusted colleagues, mentors, and review update as necessary. If you are early career postdoc or going to a PUI or going to start a new research lab or research project, remember that when you apply for teaching or faculty positions these days, research plan is one of the required, almost in most of the applications, research plan is one of the required documentation. So it's not necessarily to get you to the interview, but think through when you put this research plan, research document, think through what you are going to do, and most importantly, is it something that is feasible to do? And that leads to the next bullet point: ensure your research can be established and sustained at your institution. For most of us, if you are coming fresh from our, say, PhDs, then we probably have worked, not probably, definitely we have worked on an institution that provide PhD programs, where we have seen all the instrumentation that needs for us to carry out that project. If most of the time we might continue what we did for our PhD program at the very beginning, so then we might, some of the things that we take for granted at our PhD granting institution, we might not have, especially if you move into a PUI. So then make sure your research can be established, and we'll talk briefly about the sustainable part at the end. And most importantly, is it even possible to conduct this research? And ensure that your chairperson, retention committee, and you are on the same page, especially if you are getting for a new position. If you're getting a new position, this is part of your discussion with the chair or the committee, whether you can do or what your startup package might be. Some of these fine details we can talk a little later as we move forward, but these are some of the things to keep in mind, and be clear about what you need and what is yours. If you are a theoretician, you might think I just may only need a computer, but remember, to keep your computer, you need to have a place. If you are bringing in students, undergraduate students, you cannot have 2 or 5 undergraduate students coming to your office to do their research. So those are some of the minor details that we might forget. And so therefore, irrespective of your field, your discipline, you need some space. And space, you only realize when you get into your institution that these are sacred places that people fight over to get some of those spaces. So keep those things in mind as well. Next slide, please. And this is something important that actually I did not plan ahead, because I thought the research time blocks. It is something that when I put my first calendar during my first semester, I had nice teaching blocks, and then every place is kind of empty. So I felt like, okay, now I have pretty much more free time, and I didn't intentionally allocate the time for research. Only the next semester I realized that it is not going to work. So one kind of quick word of advice from experience: make sure that protect your research time blocks, and consider it as just as your regular meeting or class, that you cannot just give up for anything else. And one thing to keep in mind is make sure that your research plan incorporate the effective use of the semester, winter, and summer sessions. Depending on your course workload, you might be able to adjust the workload of your research, but make sure every semester to have that continuity for yourself, and most importantly for your students, that you block those time slots. Next slide, please. So why we are here is to discuss how to incorporate undergraduate students. And as I said, our experiences and your experience might be different from each other. But when we bring in undergraduate students, the first thing is, irrespective of their background, they are helpful. We, especially in the physics program at my institution, we used to have the notion that we only allow students to get into research after they complete several or some required classes. But keep in mind, we are kind of going away from that idea that undergraduate students can be helpful in advancing your research agenda, irrespective of where they are, whether they are freshmen or seniors. And one thing, irrespective of from what age you get them or you start working with them, they should have a structure with clearly defined roles. Something personally I forget, that for some of the students, for example, one of the students who came with me today, this is his first conference. So then I take it for granted that I know how to wear, how to dress up for a poster presentation, but for the student, if I'm not intentional, then they might not know what to wear, how to wear, and how to behave. So those are some of the things that we need to provide them with clear defined roles, responsibilities, and mostly achievable targets. And most importantly, talk to them at the very beginning. And to keep in mind that there is a learning curve, especially if you're coming fresh from your PhD directly to a faculty position. You have worked for the past 5, 6, 7 years with graduate students, and you think that your fresh undergraduate student is as capable as they are, your colleague. So that might not be true. So then you need to provide the structure in training, mentoring, and in depending on your field, especially with safety protocols. Especially if you are working in a wet lab in chemistry or in physics, you cannot just wear your shorts and flip-flops and come to the lab. So those are some of the things we need to kind of be mindful of. And most importantly, be flexible when working with undergraduate students, because they do take other courses as well, especially if you're working with freshmen or early students such as freshmen. So maybe we can move on to the next slide, please. And the traditional method is basically we usually work one-on-one with faculty-student collaborations. And one thing that you could bring in, depending on the size of your program or size of your student population, faculty-student research group collaboration with or without a structured peer mentoring system. I'll get into that towards the end in a little bit. And there are a few other programs such as community-based programs, consortium-based programs, and bridge programs, something that we have seen here. And also for students, depending on their background, you can consider getting them enrolled in a research course for credit and other experiences as well, including NSF REU, something that probably I think most of you are aware of. If needed, we can discuss more. Next slide, please. And again, few things to keep in mind when we are bringing in undergraduate researchers. What skills would you like students to have when entering your research program? And where and how our students develop these skills within your existing curriculum? So one thing that we did within our program itself is that we said that they at least need to take physics 1 and 2. And then we, depending on the research, we said that some of them may need to take, say, for example, E-Lab or something like that. But again, it's up to you, but make sure that when you bring in these students that you need to have a clear plan what type of skills you would like your students to have. If there is the option of you can provide them one-on-one, or else you can let them take a course before you joining the class. For example, if it is an experimental physicist, you might ask them to take the machine shop course if you have that. And yes, so you may be performing these activities in your program already, reflect on what are you doing, identify what is already being done, and promote, celebrate those efforts. Something that we started doing is bringing in students early in their program rather than waiting till they become seniors. Next slide, please. So this is what we've been doing in the past. So undergraduate research, when we say the name undergraduate research, we usually think of this what we call the traditional undergraduate research. But one of the issues that we have is faculty can't mentor all students in this apprentice style mentorship. If your area of research is popular, or if your area of research or your program has a lot of students, then you might not be effectively be able to mentor all the students the same way and provide the same quality. And then the paid experiences, they are of course cost limiting. And finally, course-based undergraduate research, one of the solutions that we in the sense the community in the undergraduate research came up with in the past, that to embed undergraduate research into courses, or course-based undergraduate research, or CUR, but it requires planning, time, and resources. So one of the solutions, maybe the next slide, please. One of the solutions that we have, some of the other institutions, including Georgia College, trying is bringing in vertically integrated projects program, VIP program. We have about, at this point, about 50 plus institutions in the US as well as around the world trying this vertically integrated program, projects program, which is, I think, more than now 25 years of success. And just to give a brief introduction to VIP, if you go to the next slide, what we see usually is this fragmentation in higher ed, that student learning fragmented by time. They take one course in their freshman year, and then there's no continuity in some courses. And then when it comes to faculty, our effort is fragmented by the mission. We need to do teaching, research, and service, especially if you're at the tenure or tenure track. And then the institutions fragmented by disciplines, departments. At Georgia College, our department is chemistry, physics, and astronomy. So all three disciplines together, but there's no, in some cases, we may not even know what the other faculty member might be doing in their respective research. So institutions, they are fragmented by disciplines and departments. So then one way VIP can bring in together is, if you go to the next slide, Carol, please, that for students, the way the VIP program is set up, the students can participate up to 3 years, and 3, or depending on how you set it up, maybe starting freshman, go up to 4 years, depending on the number of credit hours. You can move starting with freshman, and then for 1 credit and go up to the senior level, senior class, either for credit, or maybe at that point, it might be something that you can get paid. And then for us, our teaching, research, and service, it could be bring together, especially if my research, if I set up my background is in solar, if I have my solar VIP team, that research itself can be part of my teaching load. And again, these are personal experiences. Depending on your institution, some of the things that I'm saying here, we might not be able to do right away. But the VIP consortium, part of about 50 institutions, we have tried several methods of doing it. So then there's at least one institution who tried the method that you are going to try, and then have successfully implemented it. So then that's one other thing. And then briefly, if I go to the next slide, that we can bring in collaboration in low-stake environment, especially for some of our projects. We might not only need a physics or astronomy student. We might be able to work with a student in, say, who is a math major or who is a computer science major, and to get my kind of research done, meaning my kind of area of research, that particular student might be able to help with my research and get the research experience for the student. Because at the end, in most of the time, the project, this is a personal opinion, the project that you do may not really matter. The experience is what it matters. So then with me right now, I said I brought 5 students with me. One of the students who's working in my research is a biology major. So then I can bring in different students to get the work done while giving the student the experience. And then the next slide, please. Maybe we can skip these slides and then briefly tell about the model, that these are faculty-led large student teams. And in some cases, you have 10, 20 students, and examples coming from Purdue as well as from Georgia Tech. This photo is coming from a team from Georgia Tech, actually. And then you do these research experiences for credit. And there are a few other things that we can discuss, but for the sake of time, I think we can move on. And final word of advice, only you can ensure your research program stays on track. But keep in mind, there are a lot of other people who can help. So if you need help, ask. In a way, that's what we are doing here. And then although you see few faces doing this workshop or presentation, all of this material that you see were developed over the years, including Mike is here, Mike Jackson and his colleagues and everybody from CUR developed these over the years, adding one at a time to this set deck of slides. So we have learned, and I think this is a quick plug why you might consider joining CUR and Physics and Astronomy is you have a you have very good colleagues that you can lean on because they have seen almost everything. So then if you come up with any questions, you could just give a quick call or send an email because you have that people who can give this advice because they have lived those experiences. And a few other things, don't be afraid to say, I don't know, and stay focused on your objectives and goals. It is easy to get distracted with everyday deadlines. Connecting back, that why you might need to consider to have a separate time slot for your research. Keep that in mind and stay focused on achieving short-term deliverables, even if they can change from your research plan. And make sure that create and establishing your research program that should be challenging to you as well. If not with time, especially if you're in tenure track or tenured, once you receive that tenure thing, you might forget the energy or the enthusiasm you had for research. So there are a few things that you don't get much comfortable, especially because remember why most of us join the higher ed. So you need to have that spark if you need to share that light with the undergraduate students. And yes, next slide, please.
All right, so thank you so much for that introduction. We're going to move into some best practices now, and we'll have Ted get us started with this part.
Hi. Thank you again for that thorough introduction. I would like to talk to you about some of the highlights that are relevant for individual for individual researchers trying to mentor undergraduates that we picked out from the EP3 guide. And in case you haven't seen EP3, EP3 was written by APS in collaboration with AAPT and stands for Effective Practices for Physics Programs. And as such, I first want to put this into context that the target audience EP3 is a department is departments and departments and so you want to for individuals, especially those especially younger researchers like postdocs and older graduate students, it may seem like not all of these things not all of these things are applicable or even doable. But nonetheless, there's still a lot of great information. And as was mentioned before, local context is everything. And also, I want to highlight that everything we're about to say is not a to-do list, right? It's not, these aren't things that you want to copy down and say, I have to do this. You put them on mentor undergrads. Next slide, please, Carol. So this slide is essentially a graphical table of contents of EP3, and which covers many different areas of physics programs. And then the ones in the orange circle are the sections that we picked what we felt is useful content for this webinar. Next slide, please. Well, so one of the key differences between one of the key aspects I would say about undergraduate research is that it's not classes, and then so as far as best practices go, we should try to, the mentor and the PI, right, who's conceiving these projects, out to try to provide authentic research experiences that doesn't simply boil down to solving another homework problem. And in the process, we should encourage students to ask questions, But more importantly, they'll also show students that not all questions have immediate answers, right? So the fact that questions don't necessarily have immediate or even actual known answers is one of the things that distinguishes researchers from from random problems in random homework problems. And then another aspect of unauthentic research experience is the communication with other group members and researchers that comes with the territory. So we want to provide the scaffolding to encourage students to participate in group meetings and in discussions, and ensure that the students have substantial amount of time to talk, and set aside time for them to ask questions or make comments. So that is, we want the students to feel like they're active and full participants in the process in these meetings, and not just the lowly undergrad that's sitting in a corner and clueless about what's going on, right? And then and we also another aspect of an authentic research experiences is that failures and setbacks are normal parts of research, and so we ought to teach the students that these things are not to be feared, and that they can actually learn from them. Next slide, please, Carol. Well, and then as students grow in our research groups and gain more experience in the processes, the protocols, and the background knowledge, we should, as early as possible, start making students feel like they have some ownership and some scientific ownership and stake in this work. And so that is to provide students opportunities to make, or or perhaps more appropriate, participate in making critical decisions, critical scientific decisions, right? Not decisions necessarily limited to which hours should I come into lab, but more like give students chances to voice their input in what experiment should we do next and why. And then eventually we would also like students to have some independence in exploring part of the research that interests them, and then enable them to then develop their own conclusions about the part of the research that they take ownership of. And then however, that's one of these things that's easier said than done. And we really have to guide the students, right, eventually, in how to sufficiently support and defend their conclusions. Along the way, we need to teach students well, now that you have developed your own questions and conclusions, then what do you have to do to actually make sure your conclusions stand up to scrutiny in the scientific community, right? Next slide, please. And then, in terms of implementation, detailed implementation, one of the key things is to have projects with clear and manageable goals. And some of this we have written here is based on the EP3 guide, injected with some of my own experiences. Students, undergraduate students particularly, often starting our research group without really knowing anything about the topic, and they may not even have necessarily taken the classes that would enable them to talk about the science that we do at any kind of proficient manner. And so therefore, it's important to give them small or even toy model projects to begin with straightforward and compartmentalized elements and tasks. And then some of these small tasks and elements might necessarily need to involve known answers, at least answers that are known to the mentor. And we also want to set and communicate both short and long-term goals with the students, so that they feel like so that they know there's some kind of uh, longer term punchline that they're working towards and they can be excited about, but simultaneously they know that there are shorter term goals, there shorter term goals and shorter term tasks that are manageable on the time scales that they may have. And so related to that, one good practice would be to divide projects into small elements and giving students a fixed length of time to complete or at least make some progress or report back to you on those small elements. And here I want to emphasize that that it's important to also be flexible with the fixed length of time in terms of what you expect the students to actually produce, right? Because at least in my own experience, I often overshoot in what I think is a small task, and then it turns out to be overwhelming or even impossible for the students. So sometimes if the student could just I found that if the student simply produced a reasonable and insightful question in that fixed length of time, that would be a good outcome already. So I guess here the message is to give them fixed lengths of time to do compartmentalized things so that they have a timeline, a deadline, and a structure in mind. But simultaneously, as mentors, we ought to be flexible about what's reasonable for them to what we expect, what's reasonable for them to produce in that fixed amount of time. And so then that leads into my last point on the uh, slide, which is to match timeline and the project elements to deliverables with clear instructions on what the students on what the students should produce. So they ought to have some clear objective in mind of what they work towards. But again, simultaneously, we ought to be flexible in our mind that if they didn't produce that reach that objective in the length of time we prescribed, that's okay. That's perfectly fine. And the next slide, please. Thank you. And then finally, again, this is one of these things that's easier said than done. Every student is different, right? Every student have different circumstances, have the different circumstances, and especially if you have first generation students of significant family obligations. I've personally had research students who had children and who had to work like 2 jobs out of school to support their kids, and then so in particular for those students who are maybe less prepared, who may be first generation students, some of the things that we sort of take for granted are available resources that we sort of take sometimes for granted that all students should know about. They don't actually they don't know those things, and it is up to us as mentors to, for instance, introduce students to members of our department. They may not realize they can knock on the doors of other people to introduce themselves and be introduced, right? And they may not even realize how office hours work, right? And what that they could expect the professors to be available during office hours. That may be something that I've personally seen students who didn't know that was a thing that they should expect. And then we should also be proactive in talking to these students about how research works, and then how to approach someone to talk about research. And again, these are the things where we may think it's a simple question of knocking on somebody's door, but uh, there's all of these opportunities that these students may not may not know about. That is up to us as mentors to guide them towards and make them aware. Alrighty, Carol. So I turn this back to Carol.
Go for it, Justin.
So this is a really great transition into the um, some of the tangible tools that we want you to walk away with um, from this webinar. Like I said, I'm an instrumentalist. Tools are my bread and butter. If I can't use it for something, I don't know why I showed up. But before that, I do want to double down on Ted's tip regarding first generation students and students having to work. Both Becky and I went to working class college. Both Becky and I worked our way through undergrad, and we both struggled. Certainly in comparison to some of our classmates who didn't have to spend that extra. Carol's here, so we'll say 10 hours per week, since that's the
I worked 20
policy for Calbridge.
Just FYI. I started working in high school, never stopped.
Yeah, that tracks. So it is really important to be able to get a sense of where your students are in life and what the expectations surrounding their time are elsewhere in their life. Students come from all sorts of backgrounds and different cultures. And it's important to recognize, or to at least point out, that not all cultures jive well with academic culture. The expectations from some cultures are such that children are expected to stay home. The family unit survives or dies as a unit. And so leaving the house to go and do something that costs money rather than making money is a huge ask. We worked on Calbridge's mentoring handbook a few years back. A few alumni helped rewrite that handbook, and one thing that we focused a lot on was attempting to be sensitive to these things, and that pointed out the need for a functional way of actually making these connections with your students. And so that's what I'm going. That's what I'm going to introduce right now. That effort that I talked about to rewrite the Calbridge mentoring handbook was led by the woman who is now Calbridge's director of mentoring. And these documents were primarily developed by her, and we're using the documents that she actually uses in her mentoring with her undergraduate students now. So the mentoring compact is a simple document where you put in writing the expectations toward the mentor from the mentee, and toward the mentee from the mentor. Carol has linked that document. You should feel free to open it up and take a look. This is an example research compact that was provided by Dr. Katie Rodriguez-Wimberly, who's new faculty at CSU Santa Barbara. Sorry, San Bernardino. I was within a few hundred miles. And as you peruse through here, you'll find that a lot of these questions are fairly simple, but really easy to overlook. And so what this really does is it's an effective way to get out ahead of several really likely misunderstandings. It's also a way to make sure that you and your students are on the same page, regardless of the inevitable differences in upbringing and culture. And it's an opportunity for you to introduce new students to the community norms of your group. Just sort of what's expected in a group meeting or in terms of lab etiquette. And these things can serve to really ease both the transition of a student into your group and the maintenance of that student's understanding of what's expected of them. This also builds in a layer of um, accountability for you, um, which is also something that I think those in leadership can often overlook. The ability for your students to come and say, "Hey, we're supposed to meet once a week. That's what we agreed on, and I haven't seen you in a month." That's important, right? To be able to check yourself and to have for the student to have something to actually back up to, so that this is clear and understood. The next document is an individual development plan. And this is actually what we're going to use for our case studies today. This document focuses on understanding what it is your students want, right? Um, your metric of success as a mentor is the success of your mentees, right? Your job is to make them as successful as possible, as quickly as possible. Make yourself obsolete as soon as you can. But you can't help someone reach their goals if you don't know what their goals are. And people are dynamic. Goals change. Anecdotally, I was in my third year before I think my advisor discovered what it was I actually want to do. And this turned into I mean, we had it out. This was a big deal because for 3 years, he had been giving me tasks designed to help someone that wanted something that I didn't want. So finally, once we actually sat down and did something similar to developing an actual development plan for me, things started to run much more smoothly, and he was able to advise me much more effectively. Carol has linked the IDP. If you haven't opened it, you ought to. Again, this is provided by Professor Limberly. And this is a more involved document. Again, this is an example for your uses. You, I'm sure, would change this kind of document, change this document. And you can use this exact document as a starting point. And you could implement this tomorrow with students already in your lab if you wanted to. And I am willing to bet that you would discover some surprising and interesting things about your students. So it covers just basic information. It asks about career goals, objectives, and it asks about an action plan for the term. In my opinion, one of the best things about the IDP and about having these kinds of meetings and putting these things in writing with your students is it gives you a real sense of where their head is and whether or not their goals are sufficiently feasible or sufficiently ambitious. I have had a situation with undergrads in our lab where they had no clue what was available to them in terms of our lab. They had no idea the amount of money that flies around at UPenn. And so they were nickel and diming a $20 purchase. And I had to explain to them, you cost more than that in the time that it took you to make that assessment. Just buy the damn thing. Building that context is absolutely invaluable for being an effective mentor. I will say it again because I think in this kind of environment, if you've not said it 3 times, you haven't said it at all. So this is number 2, foreshadowing. If you don't know what your mentee wants to do, or what their goals are, how could you possibly help them get there? So the mentoring compact is designed to help you outline the conversation that will help you discover who your student is, where the dissonances in your expectations, your cultures, your available time are. And the individual development plan is a tool that you can employ to then act on that information. So what we're going to do as an activity, next slide, please, is we're going to break into small groups. And then while you're in that small group, in that breakout room, you're individually going to review the first case study. Matt says a lot of students don't know what they want. I had a conversation with a student yesterday evening who was having a bit of a breakdown for not knowing what they want to do. And I told him the truth. No one knows what they're doing. Just show up and keep doing your best until an opportunity that you kind of want to do shows up. And I think it's fine if a student doesn't exactly know what they want to do to delegate a little more aggressively and just say, okay, then try this. No? All right, then try this. So again, sorry, what we're going to do is we're going to break into small groups. While you're in that group, we're going to spend about 5 minutes individually reviewing the case study. And the case studies are just IDPs that some Calbridge alumni filled out based on our own experiences with undergraduates in our labs and our own experiences as undergraduates. Once we're done reviewing the case study individually, you're going to discuss as a group. And your task as a group is to write down one strategy, and you have to agree on this, one strategy that you might employ toward mentoring that student. So it could be a semester plan, it could be anything you heard today, it could be anything that in your experience is useful. And then what we're going to do is we're going to come back to the main room and we're going to share out that strategy in the chat. We're all just going to spew that text into the chat. And then we'll have a quick group discussion on some themes we see, what we think might be particularly useful or interesting that we saw from other groups. And then we're going to repeat it with a second case study. I think that's my last slide. Is that true? No. Carol linked the first example. You can open that up if you want to. Actually, you probably should open it up before we send you into breakout rooms. But for now, some guiding questions when you're looking through, thanks, Carol. When you're looking through the IDP example. What does this student need and what can you provide? I think an important thing to really consider is the student being reasonable in their expectations? Is there more information you might want from the student? And can you foresee any obvious challenges that the student is going to run into? And then finally, what kinds of strategies could you employ to address that challenge? And then I think the way I structured these slides is such that the next slide should bring us right back to the breakout room explanation. Yeah, look at me. So again, you haven't said it 3 times. You haven't said it at all. What we're going to do is break out into small groups, review individually, discuss as a group, and then write down before you come back as a group one strategy. Because if you don't know what your students' goals are, how could you possibly help them get to those goals? And I'll shut up now.
All right, so I'll open the breakout rooms in just a moment. You'll automatically move into them. The timer set for, I need to change that, 18 minutes. And then you'll get a 2-minute warning before everything closes and automatically brings you back. So that 2-minute warning is that perfect time for you to go through and write down what you're going to share out with everyone. So any questions before I open these up for folks to join? All right, then. Here we go. The rest of the participants will be coming back in about 30 seconds. But while we wait, you can start thinking about your answer to the question, what is one strategy you would employ towards mentoring this student? I'll go ahead and put up that slide. All right, Justin, you wanna?
Okay, so now the expectation is that each group will have one person from their group drop their share out into the chat. So the prompt was what one strategy uh, might you employ to try and best help this student from the get-go. So if you don't know exactly who was going to respond from your group, you can maybe try and figure that out in chat. Otherwise, it's all right if multiple people from a group drop in something similar. We can parse it in real time.
Yeah, I think we've got few enough people now that everyone should feel free to just dump their thoughts.
A quick technical question. The comments that we put during the breakout sessions, would that be available for everyone, or do we need to put it again?
Meaning if you were chatting during your session?
Yes.
Yeah, we can't see that in the main room. That doesn't translate over.
Okay.
Also, the chat says that because we have a large number of participants that they can't send chats.
Huh. Okay.
System messages for those who've joined or left have been disabled.
Okay. So why don't we just have one person from each group share out, and we'll just switch this up. We're now smaller. So we had 4 rooms, whether it was the facilitator that wants to share out or someone else. Let's just get some volunteers. Who wants to go first, or do I have to start calling on
Well,
folks?
I shared mine in the chat already, so I'll just jump in and then other folks can just follow me if necessary. So we talked about it, and you know the responses. I think everyone felt that the responses were just a little too vague. So if this was more as like a take-in form, they didn't feel that it was really as beneficial because we knew that the student wanted to do something, just what they were doing, why they were doing it, it was still kind of unclear. So they actually liked the idea of using something like this actually slightly later in the process. So maybe something where in maybe a mid-semester kind of deal, up to a mid-semester kind of deal, where maybe they first meet one-on-one with the faculty member. If the faculty member has a group, then maybe that's a follow-up with the group where different projects are being talked about. That you can start talking about the different skills that are needed or the skills that one could gain in each one of those, and then use that information so the student could go ahead and move into into filling this form out in kind of and maybe a way that they allows them to better kind of explain what they're looking for, what it is that they'd like to achieve, and what they're interested in. So for folks that were in my group, did I miss anything there that you'd like to add?
All right. And we're definitely getting some comments in the chat, so we can go through and take some of those. I mean, this one was intentionally vague because it's supposed to be that student who really just doesn't know, right? But the other thing about the IDP is that it is a living document. So I think the expectation of the way it was written was you go through it the first time, read through it, now you have that conversation. So you sort of know where to try and probe to get a little bit more. And yes, there's going to be a wide variety. Justin, I'm not trying to steal your facilitation away from you, so feel free to jump in. All right, so I'm sort of scrolling through the chat here to see what people's responses are. So a lot of it's really around early education, trying to get a better idea of what this student really wants. And maybe this is a scenario, like some people suggested, to just get them started on something and see what they like and see what they don't. I mean, I will definitely say that my first summer research experience was a great experience. I worked at the National Solar Observatory in Tucson. It was not in Sunspot. We just visited, which meant I was around civilization, which was lovely. But I learned that I really don't care about solar research. I mean, the sun's great, and it would be a problem if we didn't have it, but that was not my cup of tea. But I learned that I loved research, right? So that experience, I talked to a lot of my students about it, is that you don't have to love everything you do. It's still a learning experience. And that's why these short-term things are great opportunities to go through and explore something you've never considered of before. So the Galaxy Zoo stuff is great. There's all kinds of asteroid hunter ones too for those that are astronomy based. Timelines, absolutely. Goals, milestones. You need to know whether or not you have funds to pay the student, or if not, where you might be able to get some, or some other way of compensation, whether that's course credit or not. We'll have some resources at the end for different grant programs and stuff as well. Great. Anyone want to add anything else, or should we get ready to jump into a second one? This is a very different.
So I'm gonna have to go before the second one is done. I want to comment a little bit on sorry, trying to read and talk at the same time on some of the share outs had some of the discussion that we're having. Let's see. So Laura makes a judgment on this student that they clearly have familial responsibilities that they're going to have to overcome if they want to be an effective researcher. And I want to double down on that. And I want to push back on the idea of implementing this later in a student's research experience. I think this is actually a fairly good representation of a student that would fall through the cracks with that approach, or that would very likely fall through the cracks with that approach. And point out that something like the IDP, something like the IDP can be used to identify the things that are going to actually get in the way of a potentially valuable student actually being useful for your lab. But it's also important to consider mentoring questions not from the perspective of how are the students specifically useful to your research agenda or to your grant output, but how you are an effective mentor across cultures and across different needs. And at which points can you shore up your own approach to make sure that you are a broadly effective mentor. And I just want to, before I go, re-emphasize that something like the IDP that we've placed here could be particularly useful to any researcher who's mentoring undergraduate students or graduate students or postdocs. and that this is something that an active mentor we would expect to take and make their own, and make it useful for yourself, and continue to apply the introspection of how you can be a more broadly effective mentor. Um, and with that, I'll step off my soapbox and go talk to a potential postdoc advisor. Thanks,
All
guys.
right. So example 2 just got dropped in. We're going to mix up the rooms a little bit, but I'll go ahead and open those up with slightly less time, but same procedure as what we just went through and did. Welcome back. While our other rooms will close in about 20 seconds.
I just want to say I love this community. I'm learning so much from everyone. It's amazing. I
That's
just
great.
discovered you guys, so I'm very enthusiastic.
I really appreciate that comment. Thank you.
Alyssa, it's been a while, but I have taken students to NCUR conferences a couple times.
Yes. All right, welcome back, everyone. So it's our same share out question that we had before, but now we have a different student profile. So your answers are likely slightly different. We had 3 breakout rooms this time, just to give you all a slightly different mix. I'm happy to have people drop in the chat, or if anyone wants to unmute and say a little something about what their room discussed. Either way works for me, whatever format works best for you.
Carrie, you might have to pick on someone.
Now, if you want to go ahead and go, we've got some things I think people are typing, so we're seeing some stuff pop in the chat. But if you want to give something from your group, Ted, go for it.
Well, so we discussed the students seem to have many goals and many things he wants to learn, and it's not clear whether he's has a clear idea what any of those things are. But his other goal is to publish a paper. And so I would say we thought if he's serious about publishing a paper and having that be like the punchline of his undergraduate research experience, then he needs more advising on narrowing down his goals and what he wants he wants to work on. And we also thought this was a student who needed advising us who needed more advising that's in the form of a reality check, in terms of like not overcommitting and not overpromising.
Yes, absolutely. And we're seeing a lot of that pop up in the chat as well. So trying to be a little bit more realistic about what you might get done, or even just starting the conversation about burnout. Like you don't have to do all the things all at once. You can sort of think about what's the highest need and work yourself down from there. A lot of this one was actually based on a student that I mentored. So
Yeah, I was
she's
looking at
doing
that's
well now.
4 to 5 classes, 20 hours of research, and 20 hours of outside work. It's just I brought up in our group at Rowan, we have a hard limit of 10 hours a week that a student can work in a lab. Both our department and also I think the university has a hard limit on student hours. Just because, yeah, if they're taking 4 to 5 classes, which you almost have to do if you're going to get your major done in 4 years.
Yeah,
That student needs a reality check.
yeah, I mean, she made it, but it was not easy, of course. And things would have been better had she been able to rein back some of that stuff. Because it's definitely a situation of you're not going to be able to do any of them well if you're doing that many things. So I think that's another part of the conversation. Yeah. Anyone else want to share anything, Haley?
One of the things our group talked about as well was setting up peer mentoring with the student, maybe with a graduate student who might have a closer in time experience of understanding what research timelines are. So the student just doesn't feel like they're being dictated by this professor what they can't do and what's not possible. And that might be a helpful tool for them.
Yes, I'm a huge proponent of peer mentoring or just peer conversations. I know Becky here knows that well. Anyone else want to share anything?
So the other thing this particular kid reminded me of is a student I had, a couple of students I had before who, dabbled their hands in some lab work when they were younger, right? And then they aced all of their introductory classes. And they figured when they're juniors and seniors, they can carry the same course load and then, the same hours commitment and no problem. But that's really unrealistic because what they don't realize is Griffiths is much harder than than survey or night, right? And so but I think that's perhaps a broader issue of advising and mentoring students on research is to help them develop realistic expectations of what amount of research and types of research they can participate in is realistic as they transition from lower to upper division.
Yes, absolutely. And sometimes if you're running into maybe someone who's a little bit more stubborn and doesn't want to take the advice, you might say, okay, well, let's do a pilot. Let's try this and see how it goes. Or let's check back in a month or so and see how things are going. And if we need to make changes then we'll make changes then. I found that to be fairly successful as well, because often you don't know what it's going to be like until you're in it. And so making sure that you've got some sort of plan that everyone's agreed to ahead of time as like a backup plan, you might suggest based on your experiences that it's probably going to need to go to that, but they may not know that yet. And that's part of learning about the process and all of those things. Yeah, and I love some of the comments that are coming into the chat. All right, so we're nearing the end of our time, and I did want to share some resources with you all. One, that this virtual workshop is actually a bit of a precursor to some in-person pre-conference workshops we're trying to do this coming year. So if you're planning on going to AAS and you haven't registered, please register for our workshop. It's like $30 or $35, relatively low cost. It's the minimum that they charge. And you might be able to update your registration if you're already registered. We're hoping to do the same thing at APS in March in Anaheim. We're still working with them on that. And then potentially again at AAPT this summer, which I think is in DC in late July or early August. I don't remember the exact dates on my top of my head, and Beth left, so she can't tell us for sure anymore. So those would be designed as sort of a follow-up to this, going a little bit more in depth. And again, feel free, and we're strongly encouraging you to share these out within your networks, not just for faculty. This group actually ended up being mostly faculty. We did have a handful of grad students and postdocs, so we are thinking about ways that we can help them with their applications, not just because they often work with undergraduates in that current role, but thinking about how to help prepare people as they move into the job market. I dropped some links into the chat there about CUR. So if you are a CUR member, there's resources that come out of our division in terms of travel awards for your students that you can apply for. We've already had NCUR mentioned, that's the National Conference in Undergraduate Research. There's also regional ones that happen as well. So SCUR is the Southern California one, not actually associated with CUR, but that's a pretty big one. If you are interested in not only joining CUR, maybe you're already a CUR member, but the elections are going on for the divisional representatives right now. So that's us that are putting on this workshop. We meet 3 to 4 times a year, so it's not a huge commitment. And again, we're inclusive and open to grad students, postdocs, research staff, faculty, administrators, the whole 9 yards. I also wanted to highlight some grant programs, and some of these are relatively new. So if you are a grad student or you know of any grad students, the NSF Ascend postdoc is new, and they've done a good job. This is through MPS to scaffold it with the next one that's listed there, the Catalyst. So if you become an NSF Ascend postdoc, you then are eligible once you get a faculty job to apply for the Catalyst. And the Catalyst is supposed to be like a precursor to getting the career. So they're scaffolding these things, and they specifically are looking for effectively more broader impacts than a typical award. So they're utilizing it to try and bring in more, say, first generation, not necessarily people, but people that are supporting that diversification of our field. Then, of course, if you're looking, and you can build in all kinds of stuff to those particular grants. I think most people know about the REU. STEM is a scholarship one that I know a lot of places have used to support undergraduate research as well. Cottrell is a private one that I didn't know about until I was too late for me to apply. So it's an early career one. So I'm saying that now because I missed the boat, but maybe others won't, or hopefully others won't, I should say. And if anyone has any other resources, feel free to drop them in the chat. I see that some more stuff coming up, which is fantastic.